We're going to check out some string methods today. So we're going to type some words in a couple of text boxes and then get a lot of information about what's going on inside of them when we click this button to analyze the words. So first, we'll get the words out of the text boxes, and we're going to get rid of leading or trailing spaces by using the trim method. So I'll declare a string variable word1, and it will equal what's in txt word1.text.trim. I'll put parentheses there because that's a method that will take care of, you can see, leading and trailing white space characters. Do the same thing with the variable word2. And I'll put a breakpoint out here to show you what's going to happen. I'll start the program and type a couple of words into those two text boxes. Now I'm going to type some spaces before and after the words that I put in here. So I put some spaces before dog, I'll put some spaces after dog. And in this one I'll put some spaces and then the word cat, and then some more spaces after the word cat. Let's see what's going on. So if I hold my mouse over txt word1, you can see the spaces there for dog and cat before and after. Then I'll take a couple of steps here so that word1 and word2 now actually equal something. And notice that word1, there are no spaces before or after dog, and there's no spaces before or after cat for word2. They have been trimmed. They're still in the text of the text box, but they were trimmed before they were put into our variables. Now let's compare the two strings to see which comes first in alphabetical or lexicographical order. With string.compare, notice it's a capital S, there's two arguments here, word1, word2. This method returns a number, an integer that's either positive, negative, or 0. And all we really care about is if it's positive, negative, or 0. We don't really care what the number is. If that number is less than 0, then that first thing in the parentheses, which I have word1, that first argument, comes first. So let's check this out. I'll type in, let's see. Well, I'll go with tiger and zebra. And I'll analyze the words. Tiger comes before zebra. That makes sense alphabetically. If right now at this point I put something in where word1 would come after word2, so I'll go with elephant in this first text box and aardvark in the second one, nothing happens because elephant doesn't come before aardvark. That value of string.compare came back positive. Well, if that happens, then word1 is actually after word2, or whatever I have in those argument spots. So I'll do the same thing, string.compare word1, word2, and if the value that comes back is positive, then that second argument, which in this case is word2, that comes first. So I'll say word1 now comes after word2. We'll take a look. I'll start with cat and turtle. And cat comes before turtle. Let's go the other way this time with giraffe and dog. Giraffe comes after dog. And that's all because of the value returned by string.compare. It returns an integer. It has a value, but we really don't care what it is. We care if it's positive, negative, or 0. I'll just type else. That means we got 0 back. When that happens, both of our arguments are the same. One's not ahead of the other because they're the same thing. So they are equivalent. So in this case, when I type in the same word both times, I'll type cat into both, analyze them. Cat is equivalent to cat because string.compare returned a value of 0. And that's the giveaway that they are the same. I'm getting tired of typing or having to click on the text box every time, so I'm adjusting each tab index value right now. The word1 text box has a tab index now of 0. Word2 is going to have a tab index of 1. Analyze words button will get a tab index of 2. And exit will get a tab index of 3. I don't want to have to click in there at the start of every program. And we're going to work a lot with word1 right now, so I'm going to check this checkbox or check this radio button and make its checked property true. Then later on, if you choose to do some stuff with word2, you can click it as the program runs and analyze that. But we're going to really check out word1 right now. What would it look like if all the characters were uppercase? So LBL uppercase.text equals word1.toUpper. We'll need parentheses here because this is a method. It's going to return a string with what word 1 would look like if everything was uppercase. That could be uppercase. Obviously, numbers and spaces do not turn uppercase. So I'll use tomato for word 1. It doesn't really matter what word 2 is. I'll use beans. And there it is in all uppercase, tomato. Now, word 1 is still, in that instance, just tomato in all lowercase. I'll put a breakpoint here to show you what I mean. I'll again type tomato and beans. And as we analyze the words, I'll take a step that will execute this line of code. And we'll see that the .text property is all uppercase tomato, but word 1 is still lowercase tomato. The value of word 1 didn't change. toUpper just said, all right, I'll show you what this looks like if it was all uppercase, but it doesn't actually change the value of word 1. It's just, here's what it would look like if it was all uppercase. Well, this is what we do if we would like to see it in all lowercase, toLower. So I'll type donut with all kinds of crazy uppercase and lowercase combinations. And you see the values as returned with toUpper and toLower in those labels. Notice this, cookies with a capital C and cookies with a lowercase c. If we analyze these words, cookies comes after cookies, the uppercase comes after the lowercase. And you might think, well, what if I want them to be the same? We'll deal with that a little bit later on. Next, we'll check out the length of a string with .length. We don't need parentheses after this, but we will need to say .toString to see it in the text box because .length returns an integer, how many characters there are, and space is a character. So if I type in Pop-Tarts with a space between pop and tarts, that space counts. And the length is 9. There's 9 characters in Pop-Tarts when you include the space. This time I'll go with jelly beans. If you count all those characters up, there's going to be 10. The length of jelly beans is 10. Again, no parentheses after .length. There's a special reason for that we'll learn about much later in this course. Well, let's see if we can find the first time the letter M happens. So I'll go lbl IndexOf character.txt equals word1 .indexOf. And then in parentheses, I'm going to put an M. I'll put it in quotation marks this time. And we're going to find out the first time that M happens, if it happens. However, this also returns an integer because it's going to be a number, 0 through something else. So we have to say .toString because the index is a number. And in computer science, we start counting with 0. So if I type macaroni, the index of the M is 0. The very first spot has an index of 0. The A is at 1, the C is at 2, the next A is at 3, the R is at 4, O is at 5, N is at 6, and I is at 7. Notice the last index value is always 1 less than the length. If I go with computer, index 0 is C, index 1 is O, index 2 is where the first time M happens. Emblem has 2 M's, but we go with the first one. Index 0 has an E, index 1 has an M. That's the first time it happens, so that's what shows up on our label is the value 1. Well, we also asked the question here, what if there isn't any M? Well, let's find out. Dog doesn't have any M's in it, and the value we get is -1. That's the key to us as computer science students, that there's no M in there. It didn't find it. That returns -1. However, users of this program wouldn't know what to do with a -1. That wouldn't make any sense to them. So let's make an if word1 .indexOf M, in quotation marks here, is not equal to -1. That means we found it in there somewhere. So I'll put if it's not equal to -1, that's good. Because if it does equal -1, we didn't find it. So I'll type an else, and that's for the situation where it didn't have any M's. So if the index of the value that gets returned is not -1, we found it, and there's what the value is going to be. Otherwise, I'm just going to put n/a that it's not applicable. It's not a very big blank for me to put something in there. And that will probably make more sense to users instead of seeing a -1. So in this case, the index of M, it's not applicable. There are no M's in dog. What if we type Missouri with a capital M? That shows that it's not applicable either because there's no lowercase m in there. But what if you wanted to go ahead and count that? Well, here's where toUpper and toLower could help us out. So I'm going to go where it says word1 dot and go dot toLower before I get the index of lowercase m. Because by the time it gets to dot index of, I guarantee everything's going to be lowercase. I'll do it over here as well. So now by the time we check the index of m, every character is lowercase. So what used to be uppercase is seen as lowercase. And now for a capital M on Missouri, that will count because it's at index 0. By the time index of was looking for it, word1 dot toLower was returning a value that was all lowercase. You can look for more than just a single letter too. I'll put MAC in here. And we can look for all of that inside of our string. Remember, a substring is part of a string. So macaroni, well, MAC starts at index 0. There it is right there. If I change word1 to Big Mac, and of course I'm using dot toLower to help me out, the index is 4. That's where the Mac starts at index 4. 0, 1, 2, 3, 4. And then Mac is there. If I go with lasagna, there is no Mac in there, and we get not applicable. What if we want to find a character at a specific index? In this case, we'll check out the index of 3. So I'll have LBL index of 3.text equal word1, and then the square brackets, we're going to use them. And I'll put a 3 inside there. That returns a character. A character is not a string. So I've got to say toString. One single character actually would be inside single quotes instead of double quotes. So here's candy bar. I'll analyze these words. And the character at index 3 is D. C is at 0, A is at 1, N is at 2, D is at 3. How about if I type in the word sit? It crashes because the index we're checking, 3, is outside the bounds of the array or the whole list of characters that we have. Word 1 is sit. It goes to index 0, 1, and 2. There is no index 3. That's out of bounds. So to stop this from crashing, we will have to make an if. So if word1 dot length is, well, you're going to have at least 4 characters for this not to crash. You got to kind of think of a string as kind of like one of those bracelets that has letters that are strung into them. It's a string of characters. And again, it will just say it's not applicable if the string is not long enough. So now, sit does not crash the program. I'll type in running and walking, and the value at index 3 is capital N. 0, 1, 2, 3. Now, I could have gone with dot length instead of greater than or equal to 4, we could have said greater than 3. That would also be okay. With integers, greater than 3 is the same thing as greater than or equal to 4. So either way is correct. I'll just show you that it works just fine right here. Dog is not longer than 3. Frog is longer than 3. And so G is at index 3. 0, 1, 2, 3. I used the word substring earlier. It's part of a string, and we can use this method called substring to find a group of characters in a string. So the first value I'll put is where I want to start, index 0. That's the very start. And then the next one is length, 5. It's not the ending spot. It's how many characters we want to return. We want to return 5 of them. So if I type watermelon and picnic, I'm going with watermelon here. The first 5 characters are W-A-T-E-R. We start at index 0, where the W is, and get 5 characters. If I change this 0 to a 2, it will start at index 2 and still return 5 characters. There they are. Start at index 2 and get 5 characters. That 5 is not where to end. It's how many characters to grab for the substring. I'll change that back to 0. And I'm going to slide back up to the compare function just to remind you, in case you wanted to type it in for some notes, that if you get a negative value, argument 1 is first. If you get a positive value, argument 1 is second. And if you get 0, they're equivalent. They're the same things. Now you can go down and mess with word 2 if they checked that radio button and analyze it.